Hello and welcome to another in my series of discussions with academic leaders from around the world, leaders in engineering education. And today I really am delighted to welcome Uriel Cukierman. I've known Uriel for a number of years now, and I just want to read you a few things about his background. He currently serves as a researcher and professor at the Universidad Tecnológica Nacional, which is called UTN. He's the director of the Center of Educational Research and Innovation. He's the president of the Argentine section of the International Society for Engineering Pedagogy, a member of the Institute for Engineering Education at the National Academy of Engineering, and associate vice chancellor at the University of Emerging Technologies. He regularly teaches courses on education as a visiting professor in various universities at home and abroad, particularly on topics related to competency-based education and learning technologies. Previously, Uriel served as the Dean at the Faculty of Engineering at the University of Palermo and the President of the International Federation of Engineering Education Societies. And he's also a member of the Executive Committee of the Global Engineering Deans Council. And Uriel has taught for almost 40 years and has published 4 books and more than 50 papers and other scientific academic documents. So welcome, Uriel. Thank you for joining. And I will also say that, I think I've known you now for probably 10 or more years. I remember the first time we met, I think it was in California at a conference,
Mhm.
and we hit it off right away. We've stayed in touch. So thank you very
Mhm.
much for joining me today.
Oh, thank you. Thank you for having me. It's a pleasure to have this conversation with you and with the audience. Of course, after this video will be spreading.
Now, the one thing I want to share with everybody is that Uriel, I just went through his resume, but I know personally he's been committed to the improvement and the quality of engineering education for many years. He's been spearheading these bodies, and he regularly travels and talks about education and curriculum reform. So it's especially pleasurable to have you with me, Uriel, today. But I'd like to get started really because one of the things that I often hear is the undergraduates coming into engineering aren't really sure about what engineering is, what's the bigger picture, what do engineers do. Um, so I thought I'd ask you the question. When you started out just a few years ago, like it was maybe 10 or 15 years ago, when you first started, what were your thoughts about engineering education, and what do you really enjoy, or what surprised you about the profession?
You know, I think my own story is a little bit special, if I can say so, because I decided that I would be an engineer when I was 7 years old. When when I visited a cousin who was at that time studying, technical issues, electronics, and all of that. And I was admired by the kind of things he was able to do at that moment. And I said to me, I want to be like this man. And that was very special because it's not the it's not very common. Nowadays, unfortunately, I mean, high school students don't have a nice picture of what it is to be an engineer, what it means to be an engineer. In some cases, they have heard about very difficult mathematics and physics, and it's very tough and it's difficult. So they in some cases they say, oh, this is not for me, and this is a pity because I think that being an engineer is a very exciting thing to do. I think I mean the adults are missing the point in in marketing what it
Right.
means to be an engineer, and marketing in the good sense of it, in showing them that it showing the teenagers that this is from very different points of view. It's very good
So
because you will certainly will have a good job. You will be working in very nice places. You will be developing things that will be really awesome. So That's my point of view.
You know what's been interesting traveling the world is you get a different sense in different places. I know where I grew up in England, the engineering profession at the time, I can't really speak for it today, but it wasn't recognized in the same level as maybe a doctor or a lawyer or a professional accountant. So my father wanted me to actually go and become a professional and not an engineer. So, but I'm really happy that I took this path. But I know you're a big proponent of hybrid learning, and
Yes,
that's an area that you think that the pandemic will enable us to propel forward a bit. Would you mind describing to me what you how you define hybrid learning and what you see the benefits are and the kinds of things that maybe you've implemented or you've seen in at various institutions you're connected to?
yes, yes. Again, before the pandemic, I think, and I know that probably 90% or more of our engineering education was face to face. I mean, in school, in classrooms. Now we move to 100% out of school through Zoom, through virtual media, virtual environments. And I think that in the near future, we need to find the proper balance, the, that hybrid uh, learning in which we will have the best of both worlds. I mean, we need some hands-on. We need students uh, touching things, going to the lab, breaking things, making, learning how to work with tools, with equipment, etc. But we also need them to learn how to work remotely. And there are a lot of things that they can learn using virtual media, using virtual resources. We I think we need to change that environment in which you have 50, 100, 200 students just listening the professor in front of them. That's useless. We don't need that. We can record that session and allow them to see it, what is called the flip learning. And we need to work on that to prepare the professors to in order to allow them to do this in the correct way, because otherwise what they will do is, in some cases, they will add more theory. They will explain the theory before the class and during the class, and so that's not the point. The idea is you move the the part in which the professor speaks to a recording, and then allow the time with the professor in order to make questions, to do activities, to have the kind of things that active learning proposes.
And you believe in project-based learning and hybrid learning where you can have teams and students come together and interact and discuss. So what have you been able to do at UTN to kind of prepare your faculty to be able to do this kind of things?
Well, that's a very good question. So the first part of this equation is training the professors, in pedagogical issues. And the second part of it, let me explain in this way. I used to explain this to some colleagues in some courses that I think, and I verified that the population in general, but particularly the faculties, may be distributed using a Gauss curve. You know how the normal distribution.
A normal distribution, right?
And yes, and in one corner you will find very few faculties that are not able to change. So let them.
Don't worry.
They will eventually retire. They will be eventually retired. And on the other corner, you have the what we call the early adopters, those who are enthusiasts, those who are interested in changing things. So you need to work with that group. And then when you have a group of early adopters, enthusiasts, people that are able to show the other those who are in the middle of the curve, to show, hey, I've done this and this works, and my students are happy, and I'm happy too, and they are learning a lot, they are learning better, and I'm more interested in what I'm doing. And then the other colleagues will say, hey, what are you doing? Why don't you explain to me what I want to be a popular professor like you?
So,
And
so
how
you
do you?
so you've been putting a lot of energy into those early adopters to make sure they are really successful. I mean
Yeah.
that's a really good strategy. I mean that makes a lot of sense to
Mhm.
get them to buy in. And I guess you can take that one step further. Those professors are obviously having a good impact on their students. So what kind of reaction have you had from the students? I've seen some of the reports that you've written and the results that you've come away with. How are they responding to the use of modern technology at UTN?
You mean the students?
Students, yeah, the students.
No, the students love it. But not just the use of technology, the
Right.
proper use of technology, because it's a very different thing. You can add a lot of technology to a bad lesson, to a bad lecture, and you will have a bad lecture with technology. If the professor knows how to do it, how to take advantage of that resource in order to improve the learning.
So, I mean, you have obviously put the energy, and because of the pandemic, things have accelerated. How
Mhm.
successful has it been at UTN? Are you seeing the needle moving in the right direction?
My concern is if this movement is in the needle, will continue into that direction and not go back to the previous one. And that's I think our challenge nowadays is to take advantage of what we have done of what we are doing during this pandemic, and this rely sometimes on regulations. I'm trying to change the regulations in my own university in order to allow uh, professors to continue doing what they are doing right now, because what they are doing right now has been allowed because of the emergency. Allow them to do so. I'm interested in changing my own course. I teach communication and data networking, and I want to have 30% in classroom and 70% on a distance base. I'm not allowed nowadays to do that. So
Yeah.
I'm pushing the authorities. Hey, I want to go in this way. Allow me to do even after the pandemic.
So that's a university restriction or a government restriction?
Uh, uh, part and part.
A bit of both. Because
Yeah.
the other thing you were telling me is the is you're putting together some proposals to make some changes. Because the other piece of this puzzle is those who don't have the same resources, people who may have to have a part-time job in order to do their studies, or they're traveling a long distance, and you want to democratize the process, and the digital transformation allows for this. Maybe
Mhm.
you could talk a little bit about more about the proposal you're putting together.
Well, my concrete proposal is in this very first phase after the pandemic is to allow professors to be able to change the proportion of in classroom and distance learning. This would be a first step. Uh, National regulations allow us to have 30% of distance learning in a regular degree. But that 30% is not for each course, but for the whole degree. So we can have in that mix, we can have one course that is 100% distance learning, and another other course in 100% face to face. But this is not allowed in our own university. So changing the national regulation is much more difficult, but changing our university regulation is, of course, easier because it depends on us.
Right.
So what I'm trying to do is in this first step is to change our own university regulations and uh, allow professors to change, not in a mandatory way, but in a proposal. Of course, this is not just a matter of, okay, tell your students do what they think, not what they want.
Mhm.
No, no, you have to make
You have to have
a
projects.
plan and to explain how you will develop your how the students will develop their learning outcomes, which methodologies you will use, which kind of technology,
Well,
these different kind of things. But
you know, so the other thing, which is a topic of discussion with engineering schools, something that's obviously interesting to me, is the notion of laboratories, right? The students have to come to the university and do their labs versus what's possible now. What are your thoughts on either remote or virtual learning for students in terms of the lab
I
experience?
well, I think we have a lot of technology available to make that possible. Uh, but again, going back to what we were discussing a few minutes ago, we need to prepare the professors. We need to train the professors in order to use that technology in a proper way. Uh, it is again, it is not just to throw allow me to say, to throw the technology there and expect that it will magically work. We need to have the proper tools and also the proper training for the professors. I think we need to find a balance between these two things. I don't know if this answers your question.
No, it's a challenge because I know the use of technology is not straightforward, but the investment in teaching people the pedagogical methods, I think, is very, very important. And moving from where it was to where it could be has been accelerated by what's happened in the last few years. But the other thing, which is, front and center in everyone's minds these days, is the challenges facing the world. The Sustainable Development Goals, which exist. Um, how do you believe that those concepts and those challenges can be integrated into an undergraduate curriculum?
I think we haven't spoken about a concept that is I don't remember the exact word, real learning. I mean, learning about real things.
Right.
There's a proper word, but I don't remember it.
I think it's authentic. Authentic.
Authentic. Yes, yes. Thank you. Authentic learning. That means not learning about what works in the book. You know, learning about solving problems that are out there, that students can find when they go to their neighborhood, to their villages, and there are a lot of problems to solve out there. And we are engineers, and the goal for the engineers is to solve those problems, not to solve the problems that are in the handbook, in the professor handbook. We need to solve the problems that are the real problems that are out there, and those are the problems that are involved in this agenda of the sustainable development goal. And we need to promote uh, our students to go out there and to find the problems. That's another very important thing. We professors give the problems to the students, and that's not what happened in the real life. You
Right.
don't go to the work and your boss tells you, "Hey, I have this problem." No, you have to find out the problem first, then figure out how to solve the problem, and those are the kind of things that students need to learn. Hey, go out there, find the problems, and then try to solve them. And again, this is completely aligned with uh, with the kind of problems that the humanity, the humankind, is facing.
Right.
and we need to show, we need to guide our students to go out there to find those problems and to try to find, and then when they will have to try, when they will try to find a solution for those problems, they will need mathematics, they will need physics, they will
Right.
need chemistry, but they will need, and they will say, oh, I need to learn this because this is what it is for, you know.
So
When,
they get to understand the relevance of the
yes, because
engineering principles behind the designs they're trying to work on.
absolutely, because when you put students, particularly first year students, in one course of mathematics, one course of physics, one course of chemistry, you know, one course of algebra, what, you know, the kind of questions they do, what is this for? Why
Well,
I'm learning this?
the other question that always comes up is the classic one: is this in the exam? Am I saying, is that going to be in the
Yes,
exam?
absolutely, absolutely.
So, going down that path, I mean, I was talking to someone this morning, and it was around the subject of assessment. We're talking about modern engineering, and we want to use modern technologies, and we want to use authentic experiences to learn, but we haven't changed the assessment approach.
Absolutely,
What kind of
absolutely. Yes, I'm completely against the exams, the exam as such. I try not to use the word exam. I try to use the word assessment, and it's very important to change the words because you know, I always do an exercise when I'm offering a course or a workshop for colleagues, for professors. I ask them, I used to ask them, which is the first word that comes into your mind when I say assessment? The majority of them answer exams.
right?
And I show them that outcome of this quick survey, and that is we have those assessment and exam joined, uh, glued one to the other, and that's not the point. We need to improve the assessment methodologies. We need to assess what they are doing during the course. We need to assess how they participate in group activities. We need to assess the also the kind of mistakes they make, because you know there's no innovation without mistakes. But in our classes, in our classrooms, we punish those who make mistakes, and that's awful.
So I can't tell
uh,
you, how many times have we been at conferences and we've heard that statement: the fear of failure is something that
yes.
exists. And, and
Mhm.
and myself, as somebody who wants to bring new engineers into the company, I don't want them to have the fear of. I want them to try new things. And
Yes.
so, are you able? Do you have the flexibility in your courses to make changes to the assessment approach?
In my own course, I've been promoting and doing changes for the last 10 years. And I'm, as I previously said, as I have previously said, I'm showing my colleagues the kind of things that I'm doing, and I'm inviting them to you know, to join me in changing things. And I explain to them the kind of exercises that I do, and I explain to them that I change my methodologies each and every year, because I run surveys with my students and I learn, uh, I change things, I change methodologies, and sometimes my methodologies don't work. Okay, that's not a crime. I discovered that this methodology, this technology doesn't work. Okay, let's change it. I haven't killed any students in the process, so this is not a problem.
And that's good to get
But
to you bring the feedback. So do you involve? I mean, I know you're a big proponent of hybrid learning and project-based learning as well, and that's really important to develop those professional skills. are you able to bring those into your assessment approach? Do you try that as well?
Yes, yes, absolutely. I explain my students that if they succeed in all the different assessment processes that I do during the semester, they are not required to give an exam. So
Okay.
the exam is for those who failed in all the previous assessments, and usually these are very few.
It's interesting because I've talked to other people and they say that they sometimes get student resistance because students are used to exams and that's the way that they've been raised, right? Do you find that in some of your students?
Absolutely, absolutely. My first lecture, my first encounter with the students, the first day in the semester, I explained to them this methodology. Of course, I explained very carefully. I take 1 or 2 hours just to explain how I work with them. And at the very beginning, they are against it. They complain about it. They say, "Hey, no, but this is not what we are used to. Why are you changing this subject? We are not comfortable with this." Okay, I know you are not, but believe me, I have a lot of experience, and I show to them the surveys. I conduct surveys at the end of the year, each and every day. I have the results for the last 10 years. Sorry, for each and every year, not each and every day. And you know what I found? In all my last 10 years courses, more than 80% of the students answer that they prefer this kind of methodology in spite of the usual methodology, the, 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 you know,
The usual, your
the
traditional.
typical methodology. Yes, but at the very beginning, they show their anger. They are not comfortable with it. But at the end, they've learned, not only they've learned the subject of the course. I mean, the communication and data networking subjects, but they've learned to learn, and that's the most important goal. What I focus in my own course is to those concepts that will not change. For example, explaining what a electromagnetic wave is, what is frequency, what is how yes, the laws that are unchangeable. I focus on those subjects because these are things that will be the same in the next 10, uh, 100, 1,000 years. The Maxwell laws are there and
Yeah.
it will not change. But explaining what 4G technology is or 5G technology is, what's the purpose of that? We will have 7G or 8G in just few years, and they will have to learn by themselves. They will not come to me, "Hey, professor, you haven't explained to me 7G." No, because it, it is we don't know what it is right now. So right now what I do is I ask them to go and learn by themselves. For example, this year I will ask them to learn what it is 5G, and they will have to come to the classroom and they will have to explain the other students what 5G is. And I will ask the other students, "Hey, make question to them. Ask them what you don't understand, ask him
Right.
or her or whoever is explaining." And in this way, they learn how to learn, because that's the most important skill nowadays. Learn to learn, because apart from those essential concepts that will remain unchanged, the other things will surely change, particularly in the technology world.
So how do you, I mean, this is something which I hear a lot, is that the engineering program is already packed with so much that students have to learn, so much in 3 or 4 years you got to learn. And now we
Mhm.
have meetings, we've had many meetings with where we're talking about industry and academia. And industry wants all these things. They want students with skills ready to do the job, and they want professional skills, or sometimes called soft skills, which I don't like because I think they're really hard. They're not easy at all. Um, and the pushback from engineering faculty in some places is we don't have time. We can't put that all in our course. What you've just described is your approach, your blended approach where you have projects and you have students go out and find authentic projects or authentic issues which they can bring back to the class and at the same time learn the science and the engineering behind all of that allows. So what do you say to people who say I don't have enough room to teach them those skills? Well, what's your response?
Yes, there is a methodology for the problem is that professors usually want to put in the syllabus all the chapters in the book, and as yes, and
Yeah,
that's completely true.
yeah.
And you know the books comes each year with a new chapter because there's new technology, and the author and the publisher wants to sell thicker books because it's more expensive. But that's not the point. And when you try to put in the syllabus all the chapters of the book, it's impossible. You need more time. You need more time each year. But this is an endless game.
But you know, Uriel, I want to thank you so much. Your passion just screams through. You've been all over the world. I know you've been to many places teaching your approaches, and that last piece was really fascinating. Just the idea, because I think it's really an important one to ensure that when you teach a course or when a course is passed on to students, the fundamentally the important the concepts which are never going to change, they
Hmm.
need to be learned in the context of something which is authentic, in the context of something which is real, and in collaboration with other students. And now, if you
Hmm.
use that technology that is available today, it can be done so much more effectively by enabling students to spend 70% of their time essentially doing undergrad engineering work as opposed to sitting in a lecture theater trying to figure out what question is going to be on the exam.
Hmm.
I could talk to you for a lot longer, but you know, I know you're busy. You live in one of my favorite cities in the whole world, and I know you promised me next time I come down, you're going to cook me a barbecue. So I can't wait for that.
Absolutely.
That's going to be
You can
fun.
count on it. Yeah.
Well, thanks very much. That's what I expected. It's from the heart. Thanks very much, Uriel. I really appreciate it. Have a great day.
Thank you. Thank you.